We'll proceed in summation and integral calculus. Okay, summation and integral calculus, the formula that we are proposing, it is bringing a new ray of hope in summation and integral calculus. What formula we are placing, that it is a new ray of hope. Okay, I believe anyone would ask, what is the formula that you are proposing? That it is a kind of ray of hope. Okay, the formula we are proposing is called how to convert repeated summation into integral. How to convert repeated summation into integral. Okay, we have taken one example of converting repeated summation into integral. There are many series generally people find that are very tedious to solve. Okay, repeated summation into integration. Okay, repeated summation into integration. Like if I consider this is x-axis and I have a series called 1 plus 1 by 2, I mean 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6. What are you talking about? Consider there is a series summation sign I equal to 1 to n and then 1 by x. I equal to 1 to n, not 0 to n. Summation I equal to 1 to n, 1 by x. Okay, someone has to find this solution. What it would be? It is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Any can think about anything. What can be anything? Like 1 minus 1 by 2. Makes sense? Plus in bracket 1 minus 1 by 2 bracket close plus 1 by 2 minus 1 by 3 bracket close. Makes sense? Plus bracket 1 by 3 minus 1 by 4 bracket close plus 1 by 4 minus 1 by 4 minus 1 by 6 or 1 minus 1 by 2 bracket close plus 1 by 3 minus 1 by 4 bracket close plus 1 by 5 minus 1 by 6 plus bracket close 1 by 7 minus 1 by 8, like that to infinite. Okay, now this can be a kind of repeated summation that someone has to find a solution. Actually I was trying what is repeated summation. Sigma sign repeated summation I equal to 1 to n, 1 by I. Okay, I equal to 1 to n, 1 by I. If I take x-axis, if I take x-axis, if I take x-axis, then I is going from 1, 2, 3, 4, 5, 6. It is going in the synchronization with the x-axis 1, 2, 3, 4. So both are same. Okay. Now how to bring it to integral calculus? How to solve it? If people have watched our previous video, there we tried to find out the I forgot there we tried to find out repeated summation of uh, I okay, it was repeated summation of a to the power I, means a to the power psi I equal to 0 to n, I equal to summation sigma sign I equal to 0 to n, where n tends to infinity, 1 by 2 to the power I. So it starts with 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus like that. Then people found the solution very easily. Consider s equal to 1 plus 1 by 2 plus 1 by 4 plus. Multiply it by 1 by 2. Now 1 by 2 into s equal to 1 by 2 plus 1 by 4 plus. If you subtract, it becomes s minus 1 by 2s, that is s by 2 equal to 1, s equal to 1. Okay, now find the solution. That is summation s equal to 1 by 2 to the, I'm sorry, s equal to 1 by x. Summation equal to 1 by x. I mean, summation equal to sigma x equal to 1 to n tends to infinity 1 by x, or summation I equal to 1 to n tends to infinity, I equal to 1, not 0. 1 to n, where n tends to infinity, 1 by I. Now it will start with 1. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. This is not possible the way we did. Consider s equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, like that. If I multiply s with 1 by 2, then it will become 1 by 2 plus 1 by 4 plus 1 by 6. This is no way in synchronization with the previous one. So we cannot do s minus s by 2, s minus s by 2, and then not possible. Can someone compute? This is the question now. Can someone compute the summation, that is summation I equal to 1 to n, summation I equal to 1 to n, and then we have 1 by I. Make sense? Okay, it is not possible. I tried seeing many places. It's not possible. We will try to do from ourselves, and whatever I could do, I would tell. What is the fundamental of these are called case study now. Means these are called the apex in the in converting the repeated summation, converting the repeated summation into integral calculus. What is repeated summation into integral calculus? Okay, if I have x-axis and this is 0, at point 1 I have a height bar that is 1, at 2 it is 1 by 2, at 3 it is 1 by 3, at 4 it is 1 by 4. If I add all those, how much it will become, where it will go till infinity, plus 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 1 by infinity. Okay, in that sense, no one can calculate this summation. Anyone can try. There are 50 different solutions available in the book here and there. 50 different. There is no proof for it. Someone has this sentimental and someone has that sentimental. The question is arising that what is summation for this? Okay, consider this. If I how to convert into integral calculus. Okay, integral calculus means if I want to convert this into integral calculus, I'll repeat it again. Then summation I equal to 1 to n, where n tends to infinity, and then we have 1 by I, or fx, function over x, where x belongs to ith section, where x belongs to ith section, function over x, that is 1 by x belongs to ith section. Okay, I can rewrite this as sigma summation I equal to 1 to n, 1 by x into 1. Now 1 is the gap between each bar. If it is 0 and it is 1, then this is the bar. It is 2, then this is the bar, that is 1 by 2. It is 3, then this is the bar 1 by 3. Between each bar, there is a gap of 1. Between each bar, there is a gap of 1. If I multiply this height 1 with this base 1, it gives the area of this strip. If I add all the area of the strip, more or less it will become integration of this continuous line. If there is a continuous line called fx, function over x, and if I do fx dx, it will give the area underneath it. Fx dx, it will give area underneath it, and that area is nothing but addition of all the strip area. One strip area is fx into 1, because between two bar we have gap of 1. So I can rewrite it as summation I equal to 1 to n fx into delta xi. F small f bracket x bracket close, x belongs to ith section, xi into delta xi, the gap between delta xi, that is 1. So it is all right. The actual summation, it is in book. What is summation of 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus infinite? Now I'm trying to mold this into some formula, and formula that is coming as summation I equal to 1 to n function over x belongs to ith section, into delta xi, where delta xi is 1, constant 1, that is the gap between two bars, and fxi is the height. Now if it is in this form, it can be transformed into integral calculus, and that will be fx dx. Now fx is 1 by x dx integration from x1 to infinite. 1 by x integration is, I believe it is ln x, logarithm natural log of x. Natural log of x, that will be from 1 to infinite, or 1 to n, for what we were trying to calculate. Okay, this is the solution. Generally it is provided in the book, natural log of n. Some book it is provided natural log of n plus some constant. We will try to find out that. But this is the solution that looks like now. What is gotcha here? What is the caveat here? The caveat here is I can transform summation I equal to 1 to n function over x delta xi, provided delta xi tends to 0. Here delta xi is full-fledged 1. That's why error is there. I have to chop x-axis into n part. That is true. But the n should not be equal to infinity. N should be equal to some value. Like I'm chopping 0 to 1 section of x-axis into n different parts. And then we have, at each part I have a vertical bar. One bar is 1, second bar is 1 by 2, third bar is 1 by 3, where gap between each section is 1 by n, because I have divided 0 to 1 into n different chop, and each chop has a width of 1 by n. Okay, now in that case, if I have a mathematical formula summation I equal to 1 to n fx delta xi, where delta xi is 1 by n, okay, that can be converted into integration provided n tends to infinity. But here delta xi is 1, not 1 by n. 1 is very big. 1 by n, n tends to infinity, that tends to 0. But anyway, we got a smell now that how it should be. Because anyway, fx into 1, fx can be written as fx into 1. And that can be written as fx delta xi. And then it can be written as fx dx. This gives a loose hint that how I can convert into integral calculus. But best part is that we have to not do like this. Can I rewrite like this? Summation I equal to 1 to n function over xi, where I have divided 0 to 1 into n different parts. I am in ith section. Okay, still first section will be of height 1, second, because it dependent upon the I. First section height will be 1, second will be 1 by 2, third will be 1 by 3, like that. Okay, now can I write this fxi? Fxi is same as fxi into 1 by n? Certainly not. Fxi function over xi is same as function over xi into 1. So the actual problem is summation I equal to 1 to n fxi, rewritten as fxi into 1, rewritten as fxi into delta xi, but delta xi is 1, then rewritten as fx dx, x is 0 to infinity. But delta, to convert repeated summation into integration, the prerequisite is that it should be tends to delta xi tends to 0. Delta xi cannot be 1. Then only it can be converted into integral calculus. Okay, in that fashion now we have to be delta xi tends to 0. In that fashion, I take 0 to 1 and divide into n chop. Now can I rewrite as summation I equal to 1 to n function over xi into delta xi, that is 1 by n? Certainly not. I cannot multiply anything with 1 by n. I can multiply anything with 1, that is true. I can add anything with 0. I can subtract anything with 0. I can divide or multiply anything with 1, no problem. But I cannot multiply anything with 1 by n, thinking that it will remain the same, not possible. So this, if I want integration, then I have to multiply with the delta xi tends to 0. Someone has to proceed in this fashion. If I want in that way that fx summation of fx should be same as summation of fx delta xi where delta xi tends to 0. So I'll rewrite it. Now I have now sigma sign sigma I equal to 1 to n sigma sign I equal to 1 to n fxi. Okay, it should be same as summation sigma I equal to 1 to n fxi delta xi, where delta xi tends to 0. Not possible. Not possible. What is delta xi? Delta xi is 1 by n. So fxi cannot be equal to fxi into 1 by n. These two are equal only it is possible when right hand side fxi I convert into another function called gxi. Now it should be possible. Now summation I equal to 1 to n fxi equal to summation I equal to 1 to n gxi delta xi, where delta xi tends to 0. Now fxi is changed to gxi. What is gxi? That is the question mark. What is gxi? Okay. Now if I take one unit gap fundamental again the way we were taking. So now fxi is sampled at 1 unit gap. Fxi is sampled at 1 unit gap. That is for sure. Now what is fxi for any if if I say this is going at x, then where x equal to x at this point, what is the strip area? If I say left hand side, left hand side, how if I convert into integration both sides? Makes sense what I am saying? Okay, so this is x axis and this is function over x axis. This side we have x axis and there is a function over x axis called gx. There are two x axes. This is x axis and on top of it there is a function over x axis. This function over x axis is 1 by x and x starts from 1. There is another x axis and there is a function over x axis and its name is gx, and that is a continuous function and its function is gx. What is gx? That I don't know. What is gx? That I don't know. What you know? What I know is if someone draw a gx graph, this is a consider this is a gx graph. If someone draw a gx graph and here I have fx graph which is sampled at x equal to 1, 2, 3, 4. I have vertical bar at x equal to 1, 2, 3, 4. There is no continuous line as such. And I want to add all the vertical bar. Okay, that is exactly same as if I take one vertical bar and multiply with the 1, that is the width between two bar, then it will give an area strip. Okay, like x equal to 1, then their height is 1. Multiply by 1, that is between x equal to 1 and 2. This will give an area. So all the area strip if I add, it will become the summation what I am looking for. Okay, if I draw fx in a continuous manner, same thing 1 by x. If I draw fx in a continuous manner, and then when I know that if it is continuous manner and we are calculating strip by strip, adding strip, it is same as fx dx. But area will not be the same. What I am drawing through the vertical bar and width is 1. It is giving an intuition of that there is a rectangle. I believe it should be all right. This is the basic of the repeated summation. If I have repeated summation at x equal to 1, the height is 1. Then I multiply with the 1, then there is a rectangle of width 1 and height 1. Then I go x equal to 2. Their height is 1 by 2. I multiply with the 1, there is a rectangle 1 by 2. Then at x equal to 3, height is 1 by 3. There is a width that is 1 by 3 the rectangle. It is something like a staircase. Someone is climbing down on a staircase. Okay, in that fashion, first area is 1, second area is 1 by 2, third area is 1 by 3. We are adding area by area. If I say that I have a continuous graph and that equation is 1 by x. So now this is x-axis. When x equal to 1, the height is 1. When x equal to 2, height is 1 by 2. When x equal to 3, height is 1 by 3. Now there I had area of all the strip. If I calculate the area underneath this, this should be same, but it will not be same because if this is fx, fx dx is the area underneath it. If I take a strip by strip also, okay, then if I take at x equal to 1, then this is the height. X equal to 2, then this is the height, that is 1 by 2. The area in between is this much. This is not a rectangle. This they will go up till 1 by 2 only, and it is a rectangle. And after that, this is a more or less like a triangle. This area, what we see, this area is missing. So if I calculate the integration with width as 1, if width is delta x, that it tends to 0, then repeated summation and integration, they will come at the same platform if delta x tends to 0. But if delta x tends to 0, then I cannot say in repeated summation I equal to 1 to n fx into delta xi, where delta x tends to 0, then they will not be the same. Summation I equal to 1 to n fxi is not same as summation I equal to 1 to n fxi delta xi, where delta xi tends to 0. Yeah, both are same if delta xi is 1. Okay, anyway, now idea concept is that we have to find the solution I equal to 1 to n fxi through integration. If I want through integration, that integration talks about area. If I talk about the area, if I say integration sine x is from begin to end fx dx, it will calculate the area underneath it. And this area underneath, if fx is a continuous one and fx is a bar chart, then they will not be same, because here in bar chart, if I take the area strip, one area is a rectangle, another area is a rectangle, sub area. Where if I take fx as a continuous, each area is not a rectangle. Each area is a cut from the rectangle. So if I take like this, and this is x equal to 1, this is the height, x equal to 2, this is the height. This area will come in the integration. So where it should come like this, full rectangle should come like this. Then next this rectangle, but area is not a rectangular, and that's why disparity is there. Okay, what is solution now? Solution is that instead of saying continuous line at fx, I have to come up with another function at gx. Gx dx should be same as summation of fx. If I am able to find gx, then I can integrate it over x equal to begin to end, and I get the solution. I have to modify fx. That is the concept that we are talking about. We have to modify the fx. Now the concept is summation I equal to 1 to n, summation I equal to 1 to n fxi should be equal to summation I equal to 1 to n gxi delta xi, where delta xi tends to 0. Now we change fxi to gxi. New function will come into the picture whose multiplication with delta xi. Now there is a new function called gx. New function called gx, and this is x-axis. Now I chop this gx into innumerous parts, and each part width is delta x, and that tends to 0. Okay, in that fashion, now if I say one part is gx into delta x, gx into delta x, where I is varying. Okay, in that fashion, each part has an area of gx is the height and delta x, where delta x tends to 0. In that fashion, it doesn't matter it is a curved line or a flat line, because area will be same of a flat line or a curved line if delta x tends to 0. If it is very minute, then it will behave like a rectangle only. That is the concept of integration. Anyway, so now we have summation I equal to 1 to n fxi, where sampling has been done at the gap of 1. If sampling had been done at the gap of delta x, then we could have done something else. But anyway, when something has been done at the gap of 1, I can multiply with the 1, and I can say fx delta xi, where delta xi is 1. But converting into direct integral will not give the exact result. So we have now another function called gx. Summation of I equal to 1 to n gxi delta xi, where delta xi tends to 0. Now this is a fit candidate to convert to integration. we molded into in our fashion so that I can convert it to integration. Okay, what is your integration, sir? You tell me, anyone would ask. Okay, tell me, what is your integration now? So integration is gx dx, x is 0 to infinity. What is gx now? That is under question mark, that I have to find. What you have got? Okay, what you want? I want, what I want is summation I equal to 1 to n fx should be equal to integration sign gx dx. Makes sense? Summation I equal to 1 to n function over x in the ith section should be equal to limit of x begin to n gx dx. Okay, if it satisfies this, then we can try finding out gx. If I find out gx, then just integrate it over dx and set the limit from where to where you want. People would say, I want from 1 to 20. Means I want 1 plus 1 by 2 plus 1 by 3 plus 1 by 20. This is what I want. Someone would say, no, 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 I want 1 plus 1 by 2 plus 1 by 3 up to 1 by 10,000. Since you have a result in algebra, then anyone can solve it. What is GX? These are not mentioned in any of the book. Anyone can try. This philosophy is not mentioned in any of the book. If we had, okay, let's proceed. Okay, if that is the concept, then now what is we are trying to do? We are trying to do, consider this is x-axis and this is fx. Fx is 1 by x, that I know. At x equal to 1, it is 1. X equal to 2, it is 1 by 2. X equal to 3, it is 1 by 3. X equal to 4, it is 1 by 4. X equal to 5, it is 1 by 5. Like so, kind of fx is going on. Like so fx is going on. Okay, if I take any x, then what is the substrip area? We converted fx sigma sign I equal to 1 to n fx, x belongs to ith section, is same as sigma I equal to 1 to n fx into 1, same, where 1 is the gap between each bar, same as fx into delta xi, where delta xi is 1. We are talking about the ith section area. If every section area, what we are calculating, it is same as if I have another x-axis and gx. And for gx, I have, this is the first section, which where one line is going to here, another line is going here. And this is the area. This is the, whatever we see this line underneath it, this is the area we are talking. Whereas here in fx, we have fx is a 1 point, and we are talking about this flat area, that is a rectangle. In gx is anything. I'm not saying it is 1 by x, anything. Where the area is, 1 point is here, 1 point is here. Here down it is going as a flat on x-axis, going up and it is meeting like this. This is the area. This is the area we are talking about. Okay, this area of any I section should be same as ith section area of the fx. Then we can say all the addition will be same in generic fashion. So fx at the ith section area, fxi into 1, that is the area, should be same as gx in the ith section. What is the area of gx in the ith section? Ith section means I have one point at x. What is the height of the fx at point x, that is fx at x into 1, that is the area. If I talk about at point x, what is gx? Then someone will say gx. At x, what is the height? That is gx. If I integrate gx dx and in limit I put x to x plus 1, x to x plus 1, any x to x plus 1. If I integrate like this will give the area of a particular strip. Okay, here the area in gx, the particular strip in x to x1 is fx into 1. That is a rectangular strip. Means fx equal to gx dx x to x plus 1. This is the more minutely we have discussed. Okay, fx I know, that is 1 by x, equal to integration from x equal to x plus 1. Gx I don't know. gx dx. Okay, now in rough manner I will solve it. People can, this is a pioneer case in differential equation. People can solve it. Why I'm saying people can solve it? Because there is no solution for this problem. Anyone can search. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 up to infinity. There is no pakka wakka solution. All are meandering in space only. Someone is saying this, someone is saying that. We will try to find it as close as possible, whatever we can do right now. So fx equal to integration of x equal to x to x plus 1, that bar, that area strip, gx, I'm sorry, gx dx. If I differentiate both sides, then it becomes d of fx equal to gx. More or less, it looks like gx is d of fx. That is, if I differentiate 1 by x, it becomes minus 1 by x square. Okay, it becomes like minus 1 by x square is gx dx. Limit is x to x plus 1. It will become like, okay, I'm sorry, gx is more or less, it is like minus 1 by x square. Means gx dx altogether it will be fx only. We are starting from here. Means integration came as 1 by x, and now I have to put x to x plus 1. It will become 1 by x plus 1 minus 1 by x. That will become x. That will become x, and this side 1 plus x minus 1. It will become minus 1 by x into x plus 1. Makes sense? It will become minus 1 by x into x plus 1. Okay, this is what the, this is what net result I am getting. Gx dx integration x to x plus 1. Net result I am getting as minus 1 by x into 1 plus x, whereas gx dx is 1 by x. Okay, in that fashion. Now what you want? I want that the net result what we are getting, that is integration x equal to x plus 1 dx dx all together should become 1 by x. What do you want? I want that if I integrate, if I integrate a function called gx that I don't know, if I integrate a function called gx with dx, and integration limit is x to x plus 1 all together. First gx dx is how much? That will result in another algebra. Then if I set lower limit as x and higher limit as x plus 1, that algebra will be solved into another algebra, and that algebra should be 1 by x. That is fx. Okay, if someone can do reverse engineering or whatsoever and he's able to find gx, then he will be a pioneer now. This is this is that much powerful is the summation to integration. We have started this discussion, I believe, 20-25 days prior. Summation to integration. This is that much powerful. Okay, there is no solution for this problem. I am doing some approximation right now. We'll try to find out exact solution. How much it is coming if I consider gx dx is fx, because if I differentiate, then gx will become differentiation of fx only. Net gx dx will become fx only. If I do this approximation, then 1 by x, limit 1 x to x plus 1 will become 1 by x plus 1 minus 1 by x, and it will become minus 1 by x into x plus 1. That the net result will come is minus 1 by x into bracket 1 plus x. This result is more than 1 by x by minus 1 plus x. Next. What you want? I want a net result. If gx is what gx you have taken? Gx I have taken as minus 1 by x square, because differentiation of fx would give gx more or less. So what gx you have taken? Gx I have taken differentiation of fx, that is 1 by x. Difference gx I have taken minus 1 by x square. Gx dx will become minus 1 by x square. If I do integration, it will become 1 by x 1. Now I am substituting lower limit as x and upper limit as x plus 1. It will become minus 1 by x into 1 plus x. It is more, it, how much it should be? It should be 1 by x. How much, what difference you are getting? We are getting that it is divided by it is multiplied by 1 by 1, 1 plus x. This is extra we are getting. This should not have been there. Okay, try to revert it and multiply. Okay, now I can say, if that is the case, then I can say now my gx is now, instead of that, okay, so what is gx dx? What is gx, that we will see, or I don't know. What is gx dx? Dx earlier it was 1 by x. Now it will be 1 by x into 1 plus x by minus 1. Okay. Oh, this this is the, I'm sorry. Hope. I'll retry it. Okay. Okay. I said I don't know. Okay. So I know. I said I don't know. I know. So this is what we can try now. What we got at the end, if I had thought gx is differentiation of fx, then I started with gx equal to minus 1 by x square. Dx equal to minus 1 by x square. If I solved it, then I got it, the answer is minus 1 by x into 1 plus x, where answer should be 1 by x. What extra we are getting? Extra I am getting minus 1 by 1 plus x. Revert it and multiply and try again. That should be the solution. How you are sure about it? If someone remember, we tried this fundamental to calculate the repeated summation of a to the power x. Makes sense? Summation I equal to 1, I'm sorry, summation I equal to 0 to n. Summation I equal to 0 to n. Okay, 1 by 2 to the power I. I can rewrite as summation I equal to 0 to n, where n tends to infinity, 1 by 2 to the power I. I can rewrite this as summation I equal to 0 to n, 1 by 2 to the power x, where x belongs to ith section. I can rewrite this as summation I equal to 0 to n, n tends to infinity, function over x, x belongs to ith section, into delta xi, where delta xi is 1. Make sense? Now it will become more or less summation I equal to 0 to n, n tends to infinity, function over x, x belongs to ith section, where function over x is 1 by 2 to the power x. Now what we want? We want into integral calculus. So fx equal to integration x equal to x equal to x plus 1. Means if I take ith section here, then ith section here, or at any x, fx is 1 by 2 to the power x. If I multiply with the one delta xi, this is the area strip I am getting. If I add all the area strip, I get the solution. That is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, something like that. Okay, 1 by 2 to the power x. First it will be power 0. 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16, like that. So if I take any x I have height, that is 1 by x, multiply by 1 because gap is 1, that will give this area strip. If I add all the area strip, I get the solution. Okay, that area strip, what it belongs to any ith section, I go to another axis, and that is continuous gx line is there. There, if I take same area strip, then it's the area should be same, so that if I add all the area strip, it will be same as like this. So now fx equal to integration x equal to x plus 1. These are not there in any of the book. Anyone can try. Integration x equal to x plus 1. Gx dx. Gx dx. Gx I am considering derivative of fx, because if I derive both sides, it should be same. What is derivative of fx? That is gx we are thinking. Then derivative of fx, that is 1 by 2 to the power x. Derivative of that is ln, natural log ln 1 by 2 into 1 by 2 to the power x, because derivative of a to the power x is ln a into a to the power x. Now I can substitute here. Dx is ln 1 by 2 into 1 by 2 to the power x dx. What is integration now? The integration will come as 1 by 2 to the power x1. Now substitute x to x plus 1. It will become 1 by 2 x plus 1 minus 1 by 2 to the power x. I can take out 1 by 2 to the power x. It will become 1 by 2, 1 by 2 minus 1. It will become 1 by 2. minus 1 by 2, leave minus no, 1 by 2, a to the power, it will become 1 by 2 to the power x into 1 by 2. Actually, it should be 1 by 2 to the power x. If I see left side, it is 1 by 2 to the power x. If I take right side where I consider gx as differentiation of fx, setting x to x plus 1, it becomes 1 by 2 to the power 1 by 2 to the power x into 1 by 2. Makes sense? Or it becomes a to the power x into a minus 1 or 1 minus a. Okay, integration becomes a to the power x, a to the power x into a. Okay, this is what I think so. So integration becomes a to the power x and then limit is x to x plus 1. A to the power x plus 1 minus a to the power x. It becomes a to the power x in bracket a minus 1. And this side a to the power x is there. Both should be same. A to the power x should be same as a to the power x into a minus 1. Now, sorry. Now we are trying to bring the gx, accurate gx. This is what we want. We are estimating for the gx. We started gx with differentiation of fx. Once I get the result, then I will resettle it down. Now looks like what we got, it is 1 a minus 1 more than what we expected. Now divide it so that it will come to same situation. Let's start again. Earlier we took gx as ln a, natural log of a into a to the power x. Now divide by a minus 1. Okay, try again. Let's try again. So now we have integration ln a to the power x dx by a minus 1. But 1 by a minus 1 I can keep outside. Ln a to the power x dx integration will be a to the power x by ln a. Ln a gone. Net integration will come as a to the power x. If I substitute x to x plus 1, it will come as a to the power x into a minus 1. A minus 1 gone. It will come exactly as a to the power x. And this is a to the power x. We got the gx. What is your gx? Gx is ln a into a to the power x by a minus 1. Now it will solve all the problems. In similar fashion, here also we are trying the estimate. What extra you are getting gx if you had considered earlier gx equal to differentiation of fx. Then extra I am getting, the net result I am getting through this. Left side we have 1 by x. Right side we are getting minus 1 by x into x plus 1. Means minus 1 by x plus 1 extra I am getting. Just revert it and multiply with the to gx and try again. Okay, let's try again. I reverse it and it becomes 1 plus x by minus 1. Okay, minus I can keep outside. And what is gx earlier I had taken? Gx earlier I had taken is 1 by x square minus 1 by x square minus plus. It becomes 1 plus x by x square dx. It will become like 1 by x plus 1 by x square dx. 1 by x integration is ln x plus 1 by x square integration will be minus 1 by x. 1 by x square integration x to the power minus 2 integration will be x to minus 1 x to the power minus 1. I believe it is all right. So it will become ln x minus 1 by x. This is the solution first with the first settlement of the approximation. ln minus ln minus 1 by x. So this is the result. Now we can try limit x to x plus 1. Now we will get ln x plus 1, ln x plus 1 minus 1 by 1 plus x. This is what I think. Minus 1 by 1 plus x. Okay, minus ln, another is lx, another now another is x, ln x minus ln x and then plus 1 by x. This whole should be equal to 1 by x. Okay, if it is not equal to 1 by x, then find what is the difference we are getting. Settle it down again. Keep doing till you get the result. Anyway, let's try to see first what we got. That is the result. Let's see now. What is the result? First, what we tried with the approximation, it came as gx equal to 1 plus x by x square. That becomes 1 by x plus 1 by x square. 1 plus x by x square would become 1 by x plus 1 by x square. Integration will come as ln x minus 1 by x. Now for how much I want? Consider I want from x equal to 1 to 20. Means 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 20. Okay, if someone try, or 1 by 100, I was seeing 1 by 100, I believe it comes as 5.9 or something like that. Let's try with our fundamental. Now it will come as 1 to 100. Okay, 1 to 100, and integration is ln, ln, or 1 to 10. Let's take 1 to 10, or 1 to 100. Let's take 1 to 100. If I take 1 to 100, ln x minus 1 by x. Limit is 1 to 100. If I put 100, what is ln 100? ln 100 will be 2. Log of 100 is 2 multiplied by logarithmic of 1 by log of e. ln log of 100 base e is same as log of 100 base 10 by log of base 10 with the base e. Oh, oops, I'm sorry. Logarithmic of 100 with base e is same as logarithmic of 100 with base a by logarithmic of logarithmic logarithmic of e with base a. Same thing. So base a is 10 and e. If I revert, it becomes 2.3. Log of 100 is 2. 2 into 2.3, it becomes 4.6, something like that. 4.6 minus 1 by 100, that is 0.1. Okay, it will become 4.5. Now 1 to, now lower limit is 1. ln of 1 is 0, gone. Minus minus plus, and then 1 by x. 1 by x, that is 1 by 1 plus 1. So it will become 5.5. Okay, I believe the actual result is 4.9. There is a gap of 0.5, but if you calculate all the y, there will be gap of 0.5 in the result with this approach. But this is the final approach. Someone again can purify the way we purify the gx till it hits exactly gx dx. X to x plus 1 should be exactly fx. If we come to that gx, then that is the solution. Okay, this is okay. I'm really tired. This solution is not available in any of the book. This is our solution. Okay, if the whatever extra we are getting after doing the integration setting x to x1 plus 1 is constant, then immediately we come to result. Immediately, the way it happened in a to the power x. But if it is variable in term of x, then repeated approximation is required till we come to solution or very near to the solution. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.